Great to see you here again. My name is Luc de Koster, founder of the Koster Academy, and in this video I'm going to explain some exercise. We look at critical chain and we're doing some calculations of the different buffers. We look at the project buffer, the feeder buffers, and so on. That's the thing for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look at how we can improve the estimations of the duration. Now, when we look at task variances in the proper way, we have to look at these things. First of all, when we look at tasks at 90% level of certainty, when we add those elements, when we add the standard deviations of all those activities, we get a large overestimation in project durations. We cannot just add standard deviations. So we have to look at it. We are having different elements influencing each other, so we have to be careful what we're doing. From statistics, we know that we cannot add standard deviations, but we have to add variance instead. We looked at this already when we were looking at the PERT and the 3-point formulas applied on projects. When we looked at the critical path, we calculated the standard deviation of the critical path by adding the variances of the different activities on the critical path and then taking the square root. So what we have to do, let's say that we have n tasks with the same standard deviation sigma, then we find that the total standard deviation is sigma multiplied with the square root of n, and that's smaller than sigma multiplied with n. So this is a clear indication that we have to take into account that we have to add variances in order not to exaggerate the total standard deviation and the total duration of the activities. Now, it brings our estimates to an acceptable level instead of accumulating the uncertainty. So that's very important to understand what we are going to do here. What's the principle? Now we have uncertainty and buffers, and we accumulate the reserves that would result to overestimation of the project duration and bad performance. So what we have to do is we have to identify the 90% probable estimated value, which I call E90, or expected duration, 90 at 90%. We have different ways to identify that. We looked at PERT and 3-point. Then we looked at the 50% probable estimates. We can say in a simplification that it's half of the 90% estimates. We calculate the project duration in both cases. So we calculate it with 90% probability estimates and with 50% probability estimates. And half of the difference is the estimated project buffer. We do the same for non-critical paths, and we add a feeder buffer where the non-critical path connects to the critical path. And finally, we have a reduced planned duration of the project, which gives us a better performance like we've seen before, because the people will start working on the activities faster. We have limited the student syndrome. We have certainly limited also Parkinson's law and some other advantages that we have. Now we can have an example here to calculate the project buffer. Here we have the different activities which are on the critical path. We have the original duration, so which means 90%, and then we have the duration with 50% probability. I didn't take 50%, so some of them I have 50%, but I looked at it, really the people had a look, what is my 90% estimation and what is my 50% estimation. Different ways to calculate it, so we found these results after estimation, after discussion with the people, after some calculations. So when we look at the project buffer, we see that E90 is 54 days. E50 is 28 days, so the difference between the two is 26 days, and I find the buffer is half of the difference, so it's 13 days, and we add this to the 50% estimate, so 28 plus 13 is 41, so the project duration in our case is 41 days. Let's now have a look at an exercise in which I will calculate the project and the feeder buffers. Let us consider this project. I have 3 activities on a non-critical path and 5 activities on the critical path. We have activities A, B, and C, which are on the non-critical path with a respective duration of 10 days, 12 days, and 10 days. And their 50% duration are 4, 6, and 4 days. We have the same for the activities D till H. D has 10 days as original, 90% duration, and 6 days at duration at 50%. And we have it for the other activities the same. You see they're not exactly the 50% rule, but let's assume that we got this information by discussion with the people who will be working on these activities and who are subject matter experts. So we have for them 90% and 50% duration estimate. When we look at the critical path with the 90%, we see that we have 54 days. The non-critical path also with 90%, there are 32 days, and we have a total slack of 22 days. The critical path, when we calculate the critical path with 50% probability, we find that it has a length of 36 days, and the non-critical path at 50% is 14 days. Now we look at the feeder buffer, so we have to make the difference between the critical path and the non-critical path at 50 and at 90%. So 32 minus 14 is 18, divided by 2 gives us a feeder buffer of 9 days. And when we look at the critical path, 54 minus 36 is also 18, so we find a project buffer of 9 days. When we put this on the schedule, we first find the critical path, we find a total of 54 days, and the non-critical path, where we have the 3 activities A, B, and C, with a total duration of 32 periods, and it is linked to the critical path after activity G, for example. Now we can look at the other elements. Now we look at the buffers that we get. So we have the critical path where we put the durations like we had before, and we add also the non-critical path where we have the reduced durations. For the critical path, we can add a project buffer of 9 periods, which brings us at a total duration of 45, and we have a feeder buffer at the non-critical path, which has a duration of 9. So basically what we have here is the new schedule, and now we have to add the critical chain to that. I didn't do it here, but these calculations are already very interesting because they can help you reduce the problems on your project. You can work with the buffers, and the advantage is as long as the critical path or the non-critical path is not moving outside of the 45 periods in this case, we would not have to report any delays to the customer. And that's already very interesting because when you keep on reporting delays or changes, now you say, okay, our plan date is 45 days. You don't have to report any changes, which creates more stability in your reporting and your project work. So that was it to calculate the feeder and the project buffers. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you, and I'm looking forward to seeing you in our next videos. Bye bye.